Hello everyone, I hope you're doing well. So this video we're going to discuss the solutions to the first two problems of Codeforces round 833, which was written for division 2. So let us quickly start with the first problem. So this problem says that we have been given in rectangular blocks which are numbered from 1 to n. So for the ith block, the height will always be 1 and the width will be the seal value of I by 2. So and we have to tell we have to form a square in such a way we can use in any of those blocks, and we have to form the square without rotating any of them. So like these are the two rules, that we can use any number of blocks and we have to use them without rotating, right? So following these two conditions, we have to form a square of maximum size, right? So maximum size means maximum width. So let me just give you an example. For I is equals to 1, so for I is equals to 1, the square would be of this size. For I is equals to 2, it is still of this size because this is seal of 0.5, this is seal of 1, so this is for 2. For 3, it will become like this, right? So this is seal of 1.5. For 4, it will become like this, so this is seal of 2. For 5, we'll have 3 width, so this is seal of 2.5, right? And we keep on going on like this. This is seal of 3, and let me just write two more values. So this is 7 and this is 8, right? So this will be the seal of 3.5 and this will be the seal of 4, right? Now, so we have been given a value n, so these are numbered from 1 to n, and we have to form a square of maximum possible side, right? So what we can do is, we can, for example, if n was equal to 7, if n is equal to 7, we can easily solve it by taking the current square. So for example, if I take this square, a rectangle rather, so this is a rectangle like this. Now I can use all of the remaining rectangles to complete the square. So for example, if I choose 1 and 6 together, so if I am choosing these two boxes, the first one can be like this and the second one can be like this, right? So one is of width 1 and other is of width 3. Now what I can do is, now I can choose 2 and 5, right? Now let me just write it, the third part on the left side and one here, right? Again I can pair these two and then write it as 2 here and 2 here. So essentially this would be a square. It does not look like a square, but it will actually be a square of size 4 cross 4. So so there are 4 rows and 4 columns in every row, right? So for 7 we could form a pattern like this. Again for 8 we can choose this box, we can just ignore 7 and then again using the remaining ones we can form a similar pattern for 8. So we observe that for any value n, we can always form a square of size seal of n. Now we can also calculate seal of n as n plus 1 by 2. So for any given input n, my answer would be straight away n plus 1 by 2. So the only thing is, we can form square and square boxes, and you can observe it by doing some case work, and the answer for every test case for any given input n would be n plus 1 by 2. So let me just show you the code directly. So it is nothing, just I've taken an input n and I've just printed n plus 1 by 2, and this would be my final answer. Now moving on to the second question for today's contest, which is diverse substrings. Now this particular question says that any non-empty digit string is diverse if the number of occurrences of each character in it doesn't exceed the number of distinct characters in it. So here are given some examples. For example, let us have a look at this. Now in this particular string, there are two distinct characters, that are 6 and 8, but 6 is present 3 times, which is actually greater than 2, right? So no string should have a frequency greater than the number of distinct characters in that particular string, right? No character should have a frequency greater than the number of distinct characters in that string, and if it is less than or equal to the number of distinct characters, then it is called a diverse string or a diverse substring, right? Now we have been given initially a string of length n consisting only of digits 0 to 9, and we have to find the number of substrings of S which are actually diverse. So we just have to find the number of substrings. Now this question can be solved with a very important observation, and that is, for example, in any given string, if we are only considering the numbers from 0 to 9, that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If we are considering only these numbers, the maximum number of distinct characters in any of those strings can be 10, where all of those character is unique and the number of distinct characters is 10. So from all characters from 0 to 9 should be present in the string, right? Now for a string to be diverse, then the frequency of each character should be less than equal to 10, right? So if I take 0, 0, 0 10 times, so this is 10 times, then 1, 1, 1 is 10 times, similarly for 2, that is 10 times, and similarly up to 9, which is written 10 times, right? So this string should be diverse. So this is the maximum or the maximum string which is maximum in length possible diverse substring, because for each character the frequency is 10, which is equivalent to the number of distinct characters in the string. So this is the longest possible diverse substring or diverse string, right? So this kind of string which is having 10 characters, each of length 10, right? So the total length of this string is 100. Now even if I add one more character to this string, it should be among these characters 0 to 9. Now as soon as I add it, so as soon as I add my 101st character, it could be any of those 0 to 9. Now as soon as I add it, the number of distinct characters would still remain 10, but the frequency of one of those characters would become 11. So the resulting string would not be diverse. So we have observed that a string can be diverse up to a length 100. As soon as the length is greater than 100, it cannot remain diverse. So we can just check for all strings of the given input which are of maximum length n, right? So because maximum length 100, because 100 is the maximum length of any diverse string, right? So we can just brute force through all the strings. Now let me just show you the code directly, it will be easier to understand. So I've taken input n and string s, so I've initialized my answer with 0. Now I run a loop from 0 to less than n, and I create a frequency array of size 10, right? So I am starting from the ith position and I have to form substrings from this particular position. Now I traverse from j from 0 to less than 100. So this is less than 100 because I can use a substring of maximum 100 length, because any substring greater than 100 length would definitely not be a diverse substring, right? So I have to check for this condition, and I also have to check whether I plus j is less than n. So I use both of these conditions with and I use j plus plus. So every time I encounter any of those characters, I just increment its frequency. Now I can count the distinct characters and the maximum value or the maximum frequency of any of those characters. I just traverse through all the values from 0 to 9, right? And if f of z is positive, then the number of distinct characters is incremented by 1, and the maximum frequency, I just take maximum of next comma f of z. So I'm just taking the maximum frequency of all the characters from 0 to 9. Now if the maximum frequency of any of those of the maximum character is less than or equal to the number of distinct characters, then this is a diverse substring and I will increment my answer. Otherwise I will just go through the next substring. At the end I can just print out my answer, which is the number of diverse substrings of the given input s. So this would be the final solution for the second problem. And this was it for today's video. I hope you guys were able to understand the solutions. So till the next video talks, keep coding, stay safe, bye bye.